Welcome to the class. In the calculation of the assay of ibuprofen, we first need to prepare 0.1 molar NaOH solution. In this video class, we will learn how to prepare 0.1 molar NaOH solution. To know how to prepare 0.1 molar NaOH, we first need to know that what is molarity. Molarity is the measure of the strength or the concentration of a solution. The strength or the concentration is given as moles per liter. Molarity is given as number of moles of solute in gram equivalents divided by the liters of solution in which the moles of the solute are present. This would give you the number of moles of solute in grams per liter of the solution. Now suppose if there is a 1 mole of solute in grams present in 1 liter of the solvent, that would give you a solution that has got a strength of 1 molarity. Coming back to our question, we were discussing as to how to prepare 0.1 molar NaOH. But before this, let us first try to see how to prepare 1 molar NaOH first. So 1 molar NaOH would mean 1 mole of NaOH in gram equivalent dissolved in 1 liter of the solvent. That would give you 1 molar strength of NaOH solution. Alright. 1 mole is the Avogadro's number, which is 6.023 into 10 raised to the power 23 molecule. So that would be the weight in gram of 6.023 into 10 raised to the power 23 molecules of NaOH. This weight in gram of this much molecules or 1 mole of NaOH is called as the molar molecular mass. What is molar molecular mass? It is simple. It is the sum of individual atomic masses. And how do we obtain it? It is obtained by 2 steps. First, by multiplication of the number of moles with the individual atomic masses, and then by adding up or summing up these multiplied values. Now, for NaOH, the 1 mole of Na is present. That's why I have written 1, and 22.989 is the atomic mass of Na. Similarly, 1 mole of oxygen and 15.999 is the atomic mass of oxygen, and 1 into 1.00784, which is the atomic mass of hydrogen. So this represents the number of moles and this the atomic masses. First we multiply and then we add up the multiplied values. This gives us this figure, which is 39.99584 grams. This is the molar molecular mass of NaOH. This is the mass of 1 mole of NaOH. This is the mass of 6.023 into 10 raised to the power 23 molecules of NaOH. This is the molar molecular mass. And this much mass, if it is dissolved in 1 liter of solvent, would give you a solution of strength of 1 molarity. Now, we already know that to prepare 1 molar NaOH, we need to dissolve 39.99584 gram of NaOH in 1 liter of solvent. This weight is the molar molecular mass of NaOH, or the weight in grams of 1 mole of NaOH. And when this weight is dissolved in 1 liter of the solvent, we will get 1 molar NaOH solution. Now, for preparing solution of any molar strength, say X, if you want to do that, then what do we need to do? Then take this 39.99584, put this as denominator divided by 1 into X, which is the desired strength, and that would give you the grams of NaOH required to prepare a solution of any molar strength, means X molar strength. To check the authenticity of this formula, we would first check it for a solution of molar strength that is half of its value. that would be 0.5 molar NaOH. Without applying this formula or without putting the value of X as 0.5, we can calculate it in our mind that the grams of NaOH would be half of this value, just because the strength is half of it. So this would be half of this value. That would come around 19.99 gram of NaOH. However, for checking the authenticity of the formula, when we put the value of X as 0.5 and calculate, we would get a value that is in confirmation with that of the expected value, that is half of the value required for this. So that actually, this result actually authenticates the formula that is here. For re-verifying the formula here, we can check it for a solution of strength that is 1/4 of its value. That would be 0.25 molar NaOH. Without putting the value of X as 0.25, we can well calculate it in our mind that for making a 0.25 molar NaOH, we need a weight that is 1/4, that is 1/4 of this value, right? So the 1/4 of this value is somewhere near 9.99. However, for verification purpose of this formula, when we put the value of X as 0.25 and calculate, we get a value that is in confirmation with that of the expected values. As both of these values are in confirmation of the expected value, this only indicate that the formula given here is authentic and it can be used for calculating the grams of NaOH required to prepare a solution of any molar strength. Now we can confidently calculate the grams of NaOH required to prepare 0.1 molar NaOH. For this, we just need to replace the value of X here as 0.1 and calculate. When we calculate, we get the value as 3.9958 gram. Rounding off will give us 4 gram. So 4 gram of NaOH dissolved in 1 liter of the solvent or 1000 ml of the solvent would yield a 0.1 molar NaOH solution. Now suppose there is a situation in the lab where only 100 ml of solvent is available or 100 ml of water is available, then how do you prepare 0.1 molar NaOH? Well, to prepare 0.1 molar NaOH, we already know that if 4 gram of NaOH is dissolved in 1 liter of the solvent or 1 liter of the water, which is 1000 ml, then you would get 0.1 molar NaOH. We know that, we have seen it. For 1 ml of water that is present in the lab, the grams of NaOH that would be required is 4. This would come in the denominator divided by 1000. So 4 divided by 1000 gram of NaOH is what would be required if 1 ml of water is present in the lab to prepare 0.1 molar NaOH. At the present situation, 100 ml of solvent is present in the lab. For 100 ml of the solvent, 4 divided by 1000 into 100. The zeros would cancel out here, and after calculation, the value that we would get is 0.4 gram of NaOH. So if we dissolve 0.4 gram of NaOH in 100 ml of the solvent or water, we would get a solution of 0.1 molar strength. Dear students, I hope the class was useful for you. If it was, please do not forget to support the channel. Thank you very much.